So moving on, now we're going to study what it's going to take Bubba to lose weight. So in a previous lesson, we found that the average person can lose 1 pound if he burns 3,500 calories, more than he consumes. So let's say that after reaching the 200-pound plateau, Bubba has said enough is enough and he has to lose some weight. All right, so here we have a table, and this table shows his weight if a certain number of calories are burned. Now, this is going to be over time. So his weight, his starting point, he hasn't burned any extra calories over what he's taken in. This is his starting point for his weight loss journey. Hasn't burned any calories, he weighs 200. But as he burns more calories in thousands, so this would be 14,000 calories, he'd weigh 196. If he burns 42,000 calories, he'll weigh 188. 42,000 calories above what he takes in. So this is going to be over weeks or maybe even months. Find the slope of the line based on the data in the table. Use weight for the y-coordinate and thousands of calories as the x-coordinate. Recall that slope is the change in output divided by the change in input. So slope is going to be y2 minus y1 over x2 minus x1. And I think I'll use these 2 points here. His starting point on his weight loss journey, 0 to 100, and 14,000 calories, then he'll weigh 196. This is x1 and y1. This is x2 and y2. So my slope is going to be 196 minus 200 over 14 minus 0. 196 over 200 is negative 4 over 14. And negative 4 over 14 can be reduced to negative 2 over 7. So my slope is negative 2/7. Down 2 pounds for every 7,000 calories he burns more than he takes in. Down 2 pounds for every 7,000 calories over what he takes in. So that's my slope. So now we're asked to write a linear equation to describe weight loss. So remember, linear equation is y equals, what's my starting point? He started at 200 pounds, and now we're going to subtract, because this is a negative slope. Starting point minus slope times the variable along the x-axis. And so this would be calories burned. So here is my linear equation for his weight based on the number of thousands of calories he's burned over what he's taken in to eat. So let's go ahead and say what that means. We'll interpret that. So restate your answer. Restate your answer. If x represents thousands of calories above what he's taken in, kind of a long one, x represents thousands of calories above what he's taken in, then y equals 200 minus 2/7 x represents his new weight. Based on that number of calories. Number 11. Use your equation to find Bubba's weight if he burns 50,000 calories above what he consumes. Y equals 200 minus 2/7. And remember, this is in thousands of calories. So the number 50 here does represent 50,000 calories. So that's going to be 185.7 pounds when you put that in your calculator. And here they say to use our equation to find how many extra calories Bubba would have to burn to get back to his weight that he started college, which was 170. 170 equals 200 minus 2/7 x, and x is going to be number of thousands of calories. All right, so we're going to subtract 200 from both sides. Negative 30 equals negative 2/7 times x. Okay, so we want to get x by itself. Right now it's being multiplied by negative 2/7. To undo that, we want to multiply by the reciprocal. We want to multiply by negative 7/2. That'll remove the 7s and the 2s, and a negative times a negative is positive. But if I multiply this side of the equation by negative 7/2, I have to multiply the other side of the equal sign by negative 7/2, or they're not equal anymore. These cancel each other and become 1. And negative times a negative is positive. So x is going to be 105, which means he has to burn 105,000 calories over what he takes in to get back to his original weight when he started college of 170. And number 13, according to Mayo Clinic, a man of Bubba's size would have to burn 755 calories when running for an hour. How many hours of running will Bubba need to get back to his original weight? Okay, so we have 1 hour of running is equal to 755 calories. And we want to find out. We want to convert 105,000 calories into time. So calories cancel. We multiply. That's going to become 105,000 divided by 755. And that's 139.1 hours of running. All right, so if you run an hour a day, I don't know, I think that's a lot. But if you run an hour a day, you're going to run 7 hours a week. That's going to take 19 weeks. 19 weeks. That's going to take several months, like 4 months running an hour a day. All right, so based on this group exercise, what would have been Bubba's best approach when starting college? All right, so, exercise more. The things he didn't do. Eat less fatty foods, so eat better. Get better sleep. And basically just control calorie intake. And then he wouldn't find himself in the boat that he's in, weighing 200 pounds. Let's do this last example. Here we have a movie download service, has a $14 monthly fee. So you're going to have to pay $14 no matter how many videos you download. And then it costs $3 per movie to rent. So if we model the cost Y, the monthly cost, that's going to be model the cost of renting a certain number of movies X. X is the number of movies. What would the slope of the line be? So it goes up $3 for every movie. Our slope is going to be a 3. Up 3 for every movie. And what is the y-intercept? In other words, when x is 0, before you rent any movies, you still have to pay $14. We don't start at 0, we start at 14, and then we add $3 for every movie. So my y-intercept is 0.14, and my slope is 3. So slope-intercept form, the monthly cost is the y-intercept plus the slope times the variable along the bottom axis. This is the equation. This is slope-intercept, because slope is 3 and y-intercept is 4. This is the slope-intercept form of the monthly cost to rent these movies.